on the fly. And we're going to try this out to generate some discussions and see what your opinions of things are about subjects and topics that we're going to talk about there during this quarter. So I know most of you don't know who I am. I'm Loren Oki. I'm actually, I do have a part of the faculty in landscape architecture. You don't see much of me because I'm only 20% in landscape architecture. I'm mostly in the plant sciences department. Let's see, I have a PhD in ecology from here. I have a nursery background. My grandfather started a nursery in Sacramento. My dad and my uncle operated it. My brother and I worked there for quite a while. And that's where all my educational background was on, nursery production and greenhouse production. But I switched gears a little bit after coming here to Davis. I started working on urban water issues, and that's what the topic for the quarter is going to be. And specifically about urban development and how urban development influences water quality and water issues. So there's my contact information. Does everybody here use SmartSite? Anybody not use SmartSite? Okay, well, you and I are together. I just tried it for the first time yesterday. Has anybody gone there to the course website or SmartSite yet? No? Okay, yesterday I posted the syllabus there. If you want a hard copy of it, I have hard copies of it here. It's got the schedule of the presentations. There is going to be a writing assignment. It's supposed to be passed, not passed, so we have to have something to grade, basic grade on. So I'm going to ask you to write a really short paper, 3 to 5 pages, double spaced, so it's about a page and a half or so, single spaced. And I'd like you to discuss about 5 of the presentations that you hear through the quarter, and talk about how things that you learn in those presentations, how you might apply those to your landscape designs in the future. Okay, so pretty simple, and I don't mean it to be really technical. I just want you to see. I want to see if the presentation, the information, the presentations make sense, and if it had an impact on you, and how you might apply those the things that we presented. We pass this all the way back. There's a clicker thing coming back. Okay, so the easiest way to get a hold of me is by email. I'm rarely at my desk. So the easiest way to get a hold of me is by email. My office is over in the Environmental Horticulture Complex. If you've taken the annual plant ID classes, you'll know Jim Harding, right? So my office is just across the sidewalk from him, so in that area. So let's get started. So here's a list of a review of who's going to come. Mary Catanasso is an urban ecologist here on campus. She's going to talk about how, does this thing kind of give you motion sickness? So she's going to talk about how development affects the ecology in urban areas. Susan Culture is an advisor in the South Lake Tahoe. Her specialty is fisheries. And she's going to talk about how development has impacted fish habitat and some design features that can mitigate those issues. Can you pass these 2 back? There's 2 of these coming back to you, okay? Adina Marylander is an adjunct professor at Berkeley. She's actually housed at the Hoffman Research Center up near the central north coast. I saw this presentation that she made. She talked about how urbanization is impacting California's water supply. Aaron Majors is a contractor or from the industry. He's with Cagwin and Doherty. He's a part owner and a department manager of construction. Cagwin and Doherty, I don't know if you know this company. They're really forward-thinking on sustainable development, safe, sustainable design. And he's going to talk about some case studies of some installations that they've done in the Bay Area, and some more practical things. So this is coming back to you. Sorry. Did you get one?
No, I didn't.
Did it make it back to him back there? Julie Sayers Edmonds works for the Department of Water Resources. Should make him come here. She works for the Department of Water Resources. There's an ordinance called the Model Water Efficient Landscape Ordinance that she administers, and she's going to talk about that. Darren Haver's a really good friend of mine in Orange County. He's an advisor in water resources and water quality. He has some really neat demonstration landscapes. So if I have time, I'll show you a couple of pictures of that. Chris Bowles is an engineer in West Sacramento who focuses on ecological designs and how engineering can mitigate impacts. I think does anybody not know who Mark Truscott is? He's a member of the Landscape Architecture Advisory Committee, a local architect. He's been involved with a lot of innovative designs. One of them is the Honeybee Haven Garden out here on campus. I'm sorry, no, Kevin adored is the Honeybee Haven Garden. I'm trying to remember the name of the development. There's a developer in South Sacramento that won the California Association of Stormwater Quality Award for mitigating water quality. It's a mixed-use design. Dave Fugino is the executive director here on campus of the University of California Center for Urban Horticulture, and he's going to talk about some programs that they have. It's an outreach program that focuses on urban horticulture. Okay, so that's what's coming up. So this is the short paper I'd like you to do, 3 to 5 pages. Select 5 or more presentations and go through, discuss the information that was presented. And tell me how you think that the information that was presented would be applicable to your designs in the future. And what I'm really looking for is, I really want to see, one of the things that teachers have to measure is impact. And what I want to see is if the information that was presented during the quarter has changed your thinking or influenced your thinking about landscape design. Submit using SmartSite. This is December 10th is the last day of finals, so you should have plenty of time to put this together, I think. And because of the late due date, I'm not going to be accepting any late submissions because we have 72 hours to read and grade everything before we submit everything to registrar's office. Okay. If you want hard copies of all the stuff that I just talked about, there's some up here if you want. Okay. And all of that is posted on the SmartSite for the class. All right, let's get started. So this is the icebreaker thing. So use your clicker things. And here's the question. LDA stands for one of these 3 things, and you pick one, and you pick the number that you think it responds to. And I didn't make these words up. Lithium diisopropylamine and linear discriminant analysis. This is a chemical, and this is a statistical analysis. So what do you think it needs for us? And see up here, it's really cool up here. It tells us how many people have pressed the button. So 36 people have pressed the button. So we can pretty much tell if everybody has responded or not. And there are 45 of these out there. So 3 people. If you change your mind, if you press 3 and you change your mind and you want to press 1, go ahead and press 1. It'll register your last response. And in that little window on your clicker, it tells you what you had selected. It flashes up there for a really short time. So this means this one user feedback that says 1, somebody pressed the incorrect button. So we're waiting for that person to press the right one. But this is close enough, okay? So let's see what happens. This might take a little while. So 96 of you said LDA stands for Landscape Architecture, and for our group, that's probably the right answer, right? LDA does stand for all of these other things. So that's how this works. So this is the next question. And the purpose of these questions is to generate discussions, because I know some of you won't know the answers to these, but that's okay. So what kinds of pollutants are not often found in residential runoff? So, you drive through a neighborhood and you see this water coming off of yards. So what thing is not found on that? It's pretty obvious, right? So click your clickers. That's pretty close. Yay, everybody's got it. So the point is that all of these things are found in runoff from those front yards. This one I kind of threw in there. We really don't know that. We know that pharmaceuticals are found in sewage. Some of the pharmaceuticals that you take actually pass completely through your body, and that it ends up in the sewage. So the water treatment plants have to deal with that. Research that I've done has found pesticides, pathogens, human pathogens. I don't know about last night's homework, maybe, but definitely fertilizers and sediments. Who knows what the which of these pollutants has the most impact on California waterways?
Phosphate? Oh,
Well,
sorry.
of these.
5. Yeah, 5.
Fertilizers? It's actually sediments. And if you go through, especially in the wintertime, if you drive around the rivers, you see all that mud going through down the river. Sediment actually has the most impact. Nutrients and pesticides are way up there, but actually sediments are the number one. Okay, this one's a tricky one. This is the hard one. The toxicity of pollutants is sometimes measured in parts per trillion, so PPT, or the other thing is like nanograms per liter. It's a concentration, right? Are all of you familiar with Folsom Lake? This up piece here, right? Huge lake, right? When it's full, it holds 1 million acre-feet of water. So, compared to that, what is 1 part per trillion of something in that lake? So here's some things that you can select. Water in a 2-liter soda bottle, a 55-gallon drum worth of stuff in that lake, a rail car, UC Davis water tower, or an Olympic-sized swimming pool. If we could take that water and dump it into Folsom Lake, which one of these will represent 1 part per trillion? Just guess. It's supposed to be a fun thing. And I'll tell you that these questions, like I said, are supposed to generate discussion. The next slide, I'll tell you what the answer is and show you. Okay, so let's look. So as I expected, the answers are kind of all over the place because this is a really hard concept to grasp. We talk about parts per million of a pesticide, or parts per billion, or even a part per trillion in this case. It is really hard to conceive of what that is. It's such a small amount. Okay, so the actual answer is coming up later. So here's some math here. Okay, so here's a picture of Folsom Lake. Here's Highway Interstate 80 and Highway 57 down at the bottom. So it's 1 million acre-feet. An acre-foot is 325,000 gallons. So that means that Folsom Lake is 325 trillion gallons. Is that right? Billion gallons. 325 billion gallons, or 1.2 trillion liters. So 1 part per trillion is 1.2 liters of something in that lake. So if you took 1.2 liters of Coca-Cola and dumped it in the lake and you can mix it all up, that's 1.1 part per trillion, which is a really small amount, right? And later on, when we get to my part of the presentation, you will understand why this is such a hard thing to grasp. Organisms, fish are sensitive to pesticides at levels of parts per trillion. Okay, How often can pollutants be found in runoff from residential sources? Never, rarely, sometimes, or always. So pick your answer. And you know, this is a pretty generic question, right? Because we already know that there's a lot of different kinds of pollutants. So it's a general question of all pollutants. Always is the right answer. The research that you'll see that we've done, one of the things that we really focus on are pesticides, and we have nearly 100% detection rates of pesticides in the samples that we look at. Can landscape features affect runoff volumes? So I'm going to ask you a question. So, you know, if you don't know the answers, haven't seen it well with system. And then I want you to tell me why you think that. Why do you think landscape features affect runoff volumes? What kinds of features affect runoff volumes? This is where you're supposed to be. Topography.
Plant material.
Plant materials, pavements, so hardscape features, impervious surfaces, what else?
Soil types.
Soil types.
Amount of vegetation.
Pardon me?
Amount of vegetation.
The amount of vegetation, absolutely. So all those things affect runoff volumes. Plant selection can affect the amount of water that is required for landscape irrigation. Can plant selection also affect water quality? So the plants that you specify in your designs, does that have an effect on water quality? Couple more. Okay. Absolutely. How does it affect water quality? What kinds of things?
It can improve it because there's the plants that actually take out the pollutants and.
Absolutely. It can actually improve water quality. What else? What?
They could also inhibit it depending on the situation. If you have, for example, a strong cluster of weeds stacking up in water, it concentrates the toxins behind it, creating a bit of a chance.
Yeah, that could happen. So if you have poor placement or something and it's retarding flow, or yeah, actually what happens when that situation occurs is what she said. As that flow slows down, there's a higher residency time of those pollutants, and they actually can end up cleaning it up. That's what vegetative wetlands are for, right? They actually slow the flow of water, expose that pollutants to stuff that's in the water to plants, and actually can clean it up. What else? What about IPM? What about using native plants versus exotic species? Exotic species, probably you'll need to do some kind of pest control if you want clean plants. If you have native species, you probably won't have to do pest control because there's some native predators of those pest species, so you won't have to put on pesticides. So that's how it works. There's a substantial amount of information available on landscape plant water use. Do you agree with this? This is probably a little harder. Let's see what you think. Yeah, about split. And I was expecting that because this is kind of a trick question, is because that there are some documents that have information on plant water use. Sunset has, you know, whether it's high, medium, low water user, right? A lot of these landscape books, Bob Perry just wrote this really huge text on landscape plants in California. And it's got water use information in it. there's a document called WUCL's, Water Use Classification of Landscape Species, that legislation is using as a guide for landscape plant water use. The problem with all of them is that there's no science in it. It is all based on committees and what people think. You know, he goes, well, how much water do you think this Arctic staff list uses? How much water do you think the CNO fish uses? And everybody votes and they come up with a rating and they stick it in the book. So there's no science in it at all. It's a lot of experience, but no science. And that can be problematic. What is XBX77? Do you know what that is? You guys recognize that? Anybody recognize that? You don't? Nobody? Have you guys seen Star Trek? None of you seen Star Trek? What's the starship, the name of the starship in Star Trek? The main starship? The Enterprise, right? That's the registration number for the Starship Enterprise. Okay, I get that. All right. Okay, so let's see what this is. Yeah. It actually, SBX77 is Senate Bill Extended Session number 7, Bill number 7. It's a Senate bill. Its nickname is called 20 by 2020. And the reason why it got this nickname is the governor had mandated a 20% per capita per day water use reduction by the year 2020 in this bill. And there's a landscape component in there. So that's what that's all about. Here's a whole bunch of stuff. Assembly bills and Senate bills and other regulations, they are all landscapes. They all deal with landscape regulations. And you know what? You guys are going to be architects, right? You need to know about this stuff because some of these things, like 1881, the Water Efficient Landscape Ordinance, requires that all new landscapes must have a landscape water use budget developed. You have to predict how much water that landscape is going to use in a year. And then what happens is this is the model water efficient landscape ordinance that EWR wrote in response to this assembly bill. What happens is that when you have a new project, you have to get permits for it, right? In that permitting process, there's a landscape component that has this landscape water budget thing in it. And it has to meet these certain specifications, and then it has to, an audit occurs later on to see if what you said will happen actually is happening, whether regarding water use. Yeah.
Are these slides going to be available online?
Yeah.
With these regulations, do they affect the larger scale, like all urban planning, or also the small scale, like residential, like someone's hiring you to do the front lawn?
It depends on the city. Statewide, this ordinance says something like, for any project where the landscape area is larger than 2,500 square feet, you have to have a permit. If it's a homeowner project, or a homeowner's hired contractor, if the project is 5,000 square feet or larger, it has to be permitted. So the numbers are pretty small. City of Santa Rosa says every landscape project. There's no limit. There's no lower limit. So it just depends on the municipality. This bill that's in place, actually went into place January this year, will require that every project be permitted. The water providers will do the policing of water use because the water providers are the ones that are going to be responsible for meeting this water use reduction mandate. So, of course, if they don't comply, there's going to be fines or some other penalties. These two are, I really like these two. These two are don't know if you heard that the homeowners associations, they kind of dictate how landscapes can look. Well, this one says homeowners association or common interest developments cannot dictate, cannot prevent plants from being used that are water efficient. So they can't tell you that you have to plant turf in your front yard and you can't use water efficient plants. And this one says, it's a kind of a follow-up to it. It says that they can't tell you that you can't use artificial turf in your backyard. What does NAWA stand for? And actually, most of those are real. I only made up one of those. It's kind of weird. Guess one's with my name. Okay, so let's see what we got. Yeah, MAWA stands for Maximum Applied Water Allowance. And here's what that means. This is language that actually comes out of that Willow ordinance where this is defined. So it's the upper limit of annual applied water for the established landscape area. So there's some number that you have to calculate for a landscape project that you have to be below for that landscape water use. And it's based on a bunch of stuff. There's a reference ET. Who knows what reference ET is? There's a system in California called CIMIS, C-I-M-I-S. And it stands for the California Irrigation Management Information Service. And it was established for agriculture to give growers an idea of how much water they should irrigate their crops with. And so there's a whole bunch of weather stations around the state, and there's actually moving out of just ag areas and into urban areas because urban areas are starting to use this number to guide them in managing irrigation of landscapes and urban developments. ET adjustment factor is so a person that's using this, let's say you're a citrus grower. So there's you look up in a book or online or at CIMIS what this adjustment factor is for citrus. And you multiply these two numbers together and you get a value of how much water you should apply to your citrus crop, whether it's over a week period or a 6-month period or a 1 year period or a 1 month period. You can calculate for how much, you can estimate how much water that crop used over the same month. And so when you irrigate, you want to replace that volume of water. So urban areas, water providers are starting to use this kind of a system in conjunction with the size of the landscape area to help them manage how much water is applied to those landscapes. Okay. There's another value here, estimated total water use, and that's this number that U.S. Landscape architects or designers have to calculate. You have to estimate how much water that landscape is expected to use in a year. And when you do that calculation, you compare it to this MAWA number. If this number is lower than MAWA, then you're fine. You've done your job. If it's higher than MAWA, then you have to go back to your design and adjust it so that the water use falls below this threshold. Okay. Okay. That's the end of that clicker stuff. Was that effective at all?
Yes.
Yeah. We actually did some training, and here's a room up like that of us like this. And what I found was it really keeps you engaged. It really helps you pay attention, I guess. But it makes the whole session more interesting. And I can't promise you that any of the other speakers are going to use it. This was my first time using it, and I thought it was pretty fun. And it's actually really powerful because now I can save that. All those responses in this PowerPoint, I save it, and I have a record of that. The other thing that the demonstration showed us was that at the beginning of let's say a lecture, you get a quick quiz, 2 or 3, 4, 5 questions, to get an assessment of what you know, and then they'll repeat the quiz at the end of the session, maybe use different questions to get an assessment of learning. It was really cool. Anyway, so we're going to switch gears here, and I'm going to do a presentation on some of my research. Darren Haber, I've already talked about a little bit. Darren and I are co-PIs on this project that we've been working on since about 2004. And when we initiated this project, so this image in the back, you see that water in that gutter, right? That's what we were interested in. We wanted to know how much water was flowing into this drain and what was in it. And when we initiated this project, we looked for information to see what other people were doing. Nobody was looking at it. Nobody knew how much and what was there. So that's when we started working on this. There was a symposium Wednesday here on campus called the Water Life Symposium. Probably most of you weren't aware of it because it was the day before classes started. But we talked about this topic during the whole day. So in our study, we selected 8 study sites, and we wanted to look at only single-family homes. There's a lot of studies that they take water samples maybe out of an urban creek or Sacramento River or some water body like that, but you don't really know where that water came from. It came from every place that's upstream of that place that they collected that sample. So we wanted to see what came off of single-family homes. We selected for age. We wanted to narrow age range. There was a study in Sacramento, the city of Sacramento, that they looked at brand new homes, and they tried to improve the runoff quality from those homes. They couldn't measure an effect. So we decided to stay away from brand new homes, and we didn't want homes that were too old. So something about 16 years, the 16-year range here. The water that went down that drain, we wanted to have access to where that water came out, right out of the pipe, before it was able to run into a creek or stream where it could be modified. We selected for lot size to try to reduce variability, and we also looked at demographic of the residents in those areas to try to reduce variability. That's the problem with ecological studies like this, is that there's so much variability in just some of the things that you're looking at that you may not see any trends. So we got these parcel data with the age of the parcels from the county assessor's office, filtered out those, or selected just those lots of that age, dropped it on the Google Earth map, we got those red splotches. Then we looked at these areas for candidate sites to study. We got storm drain maps from the county drainage storm drain department, and overlaid the storm drain maps over those red areas. And we looked at, these yellow dots are outfalls. So we actually visited all the outfalls in all those red areas to see if we could find a study site. And this is one of our study sites. So what we would do is we would go to this outfall, actually look at it on the map, and go upstream, I guess, in the storm drain system. The black lines are the pipes that are into the street. We can see where the ends of the pipes are, and then kind of determine where the limits of that drain shed are. So any water that fell within that red line probably ended up in that outfall. And after we delineated that, we can look to see what's in there. So you can see there's only single-family homes here. There's a little community park. If there's some apartments. I think this is an apartment complex back here. So we didn't use that drain shed because of the apartments. So we selected 4 of these sites in Sacramento County, 4 more in Orange County. They're not real large, between 150 and 460 homes in each of those drain sheds. So water that came out of that pipe, we know which homes contributed to that pipe. We put some monitoring equipment at each of these sites. We measure how much water is coming out of the pipe, what its temperature is, the pH, some chemistry stuff, how salty it is. We put a rain gauge at each site to see what the local rainfall was there. We wanted to measure water that came out of the pipe that came from storms. So we put it. We have some automated stormwater sampling equipment, and we can talk to each of these sites just by going onto the internet. There's some really interesting things we find there. You look into pipes and, you know, we have to, there's a lot of maintenance that goes on with these things. And there's some sensors right here, there's a bunch of leaves on it. And I was going to go up there and clean it out, but he got there first, so I left. And then there's graduate students that we send up there to do the cleaning. So we started collecting water samples. In Sacramento County, we started in July of 2006. In Orange County, we started in October. We collected at a really high frequency. Weekly is really frequent. Most water studies, they might take a sample once a month, maybe once every 6 weeks or something like that, out of a river or a creek. We ended in, we actually got suspended because of the state budget thing right here, but we collected monthly through about May. And up to this point, we had collected about 700 water samples through this study, which is a huge number of samples. And we're going to try to finish up this year. We use master gardeners in Sacramento County to help us with the sampling. So we developed a citizen monitoring program and actually went out and collected the water samples. And then we also wanted to collect the early storms of each of the seasons. Why do we do that? Why are we interested in these early storms? Why do we care?
Because those have the most pollutants in the runoff.
They probably have the most pollutants. Is that what you were going to say? Yeah, so you get this rainfall and, you know, this, there's stuff that's been accumulating all summer, and you get this first rainfall and it washes everything down the drain. So this is the scene we wanted. We wanted to put the bottle right at the edge of this pipe and get that water. So from this point upstream is concrete pipe, gutter, yard. There's nothing in between. Okay? And there's a master gardener that's collecting some field data. When we collect the water sample, they also take some field data. So what do we look at? Well, we send our samples down to labs down at UC Riverside. Jay Gann is an environmental chemist who specializes in pesticide, environmental fate of pesticides. He looked at the nutrients, nitrogen, phosphorus, and here's the pesticides that we looked at, and other drinking water constituents. The project was funded by our drinking water program, and they wanted to know about these drinking water things. And we, of course, this is where we were really interested in. There's another lab down there, Marilyn Yates is a microbiologist, and she's the one that looked at all the microbiology stuff. These are pathogen indicators. Everybody knows about E. coli, right? E. coli, farm products, things like that. And there's all these other indicators. And you know, E. coli in itself really isn't a pathogen because everybody's got E. coli, right? If you have a gut, you've got E. coli. These are pathogens. These are that we actually looked at in Sacramento County. So these are indicators because they might indicate that there's a human pathogen present. We selected these pesticides. You know, there's a whole bunch of different kinds of pesticides that we could look at. Weed killer, Roundup, all kinds of stuff. Right? The reason why we selected this, diazone and chlorpyrifos are called organophosphates. You've probably heard of that term. Pyrethroids are a different class of pesticides that's different than the organophosphates. Fipronil is a fairly new one. This class is called phenylpyrazoles. All of those are ant control products. The reason why we focused on that was because the Department of Pesticide Regulation and UCI Penn did a study. They wanted to know when mom and dad homeowner went to Home Depot or Ace Hardware and they pulled a pesticide off the shelf, what did they buy and why did they buy that? And they found out 66% of all the products, pesticide products sold in California were ant control products. So that's what we focused on that. So this is what we found. This is detection frequency. So how often did we see it? So this is from the beginning of the project to about the middle of 2008. So you can see that these two red bars are the organophosphates. They've been actually off the retail market since about 2002, but we still see it. Here's that fipronil one. That's about 95%. And bifenthrin, all these orange bars are all pyrethroids. Bifenthrin is the most commonly found pesticide in your products that you buy in a nursery or hardware store. You can see that's about 97% frequency. This is Southern California. These two are 100%. In every sample that we looked at, And since this is older data, so through 2000, in the middle of 2009, these numbers are still, they still hold, but they're really high detection frequencies. So the other part about detection frequency is that, okay, we found it, but at what concentrations? So just because we found it doesn't tell you that it was a high concentration or low concentration. It just says that it was there. JGAN's equipment can see a half a part per trillion of these compounds. And we know now what a 1 part per trillion is, right? It's a really small amount. So this equipment is really sensitive. So what does that mean? So here's, I'm going to show you, I'm going to scare you with some data. This is at one of the Southern California sites. This is for the compound bifenthrin. It's that first really tall orange bar. And this is, all of these lines are samples, water samples. And I don't need you to pay attention to each of the values and all that. I just want to show you how frequently we find stuff and relative concentrations that we find it, and patterns. So the red bar is the stormwater sample, the blue bars are our regular sampling, the non-storm sampling. This red line that goes across here that's at about 10 parts per trillion. And this organism, Hyla azteca, is this benthic organism. It lives in the sediments at the bottom of the creeks. It's sensitive at below 10 parts per trillion, so that's what that number is. So you can see there's some of these spikes, and there's 70 non-storm data points and 9 stormwater data points. So here's the other 4 sites. You can see some really high concentrations, 1,000, 6,000, 688. So some really high concentrations. And like I said, this is where that high level is sensitive, about 10. The thing that I really want you to see here is that there's no patterns. We thought that we thought that with first flush storms, we would see higher concentrations during those from that washing. We didn't see it. There's some high concentration here, but this one's lower. Why was that one lower than that one? Why is this one higher during the dry season? So we didn't really see any patterns at all. So this is Southern California. Note that the concentration over here is 300. This says nanograms per liter. That's the same thing as parts per trillion. So pretty high scale here. Northern California, the concentrations are generally lower, but we still see some higher spikes. There's about 670 parts per trillion. Again, no patterns. Fipronil's the same way. Some really high concentrations, 10,000, 1,600. But again, there's just no patterns. No patterns related to storms or non-storms. So when we see these spikes, it's just chance. It just happened to be there when the pesticide was in water. Well, the other thing we wanted to look at was flows. How much water was coming out of those pipes? And I said that we measured the flow coming out of the pipe. One of the things that we looked at is how deep is the water in that pipe. Here's one set of data. First 7 days of 2008, I think. And this is just water depth. So you can see the change in water depth as the days go on. Every morning, though, you see this kind of a hump here, right? So what I did was I put this blue bar. This blue bar starts at 4 a.m. and ends at 10 a.m. So 6 hours in the morning, and it's pretty consistent, 4 a.m. to 10 a.m. So that's got to be irrigation controllers, right? Irrigation controllers, once you set them, they keep turning valves off until it breaks or you turn them on. People aren't that reliable to get those kinds of patterns. So this is a pattern we see at all 8 of our sites, this morning hump and those flows. There's a graduate student in LA, Amber Manfred. You all know Amber? You know Amber? She's been working on this project. She's been taking that flow data and the concentration stuff and trying to calculate, this L is a load. How much pesticide or how much fluid can we calculate that comes off of some area? So if we know the volume of the water and the concentration of pesticide in it, we can calculate the load. So she developed this huge equation of stuff. I'm not going to go through it, but it's really complex. So she's looking at how much pesticide is in those landscapes. Here's a graphic that she put together. This is Sacramento County. You can barely see these gray areas, but if you combine the gray areas with the green areas, that's the areas that are developed. The dark green area is low density residential. The light green is very low density residential. And if you do this math here, this is acres. So 50% of the developed lands are single family homes in the county. It's a huge proportion of land use type. So we wanted to know if we can figure out how much water is coming off of our neighborhoods and extrapolate that out to all of Sacramento County, how much water would that be? And that's what Amber did here. So this is May 2007 through May 2008. And the red, this is the runoff that she calculated would come off of all the single-family homes in Sacramento County from the storms. Okay. Then she took our data from that flow data coming out of the pipe, and she said, well, how much of the non-storm flow would come from the homes? And this is what she found. Huge numbers. Okay. Here's the totals: 38,000 acre feet from storm runoff, 182,000 acre feet from non-storm runoff. We know that Folsom Lake's 1 million acre feet, right? So that's 18% of Folsom Lake every year coming off of these homes. The other way to look at this too is that between 1/2 to 1 acre feet of water can provide the water for a typical home for a year. So that's 180,000 homes water that's just going down the drain. So I think I'm going to end here. We have 5 minutes, but I'm going to end here because the other stuff that I'll show you, you'll see from here. Did anybody have any questions? Was that the first part okay, and the second part okay too? The second part, I just wanted to show you where that information came from research like this. And those collector things, I need those back today, please.